Hello everyone, welcome to Easy Explanation. So in today's video, I'll be explaining the numerical of subnetting from subject computer network. So you can find all the notes of computer network and system from our site easyexplanation.com. From the portion courses, inside that there is computer network and security subject. Okay, so before solving this problem, I assume that you people know what is subnetting, what is subnet marks, what is CIDR notation, what are the classes of addresses. So I assume you know that. Okay, so let's go to the question. So you can see the question is, suppose an organization is given the block 17.12.40.0/26 which contains 64 addresses. The organization has 3 offices that needs to divide the addresses into 3 sub-blocks, that is 8, 16 and 6 addresses. Design the subnet. So while designing the subnet, you have to find the first address, last address, usable range and subnet mask. Okay, so you can see the diagram. Suppose this is organization. So the ISP has given this organization the address 17.12.40.0/26. Okay, so you know that slash after slash whatever number is there, for example /26 is there, so this 26 is nothing but net ID. Okay, so I assume you also know what is net ID and HID, host ID. Okay, so this is the net ID. So the total number of addresses you can find by subtracting this net ID from 32 and finding the power of that. That is 32 minus 26 will become 6 and 2 to the power 6 is equals to 64. So 64 is the total number of address as in question they have mentioned. Okay, it means that this organization has got a total of 64 address, and from this 64 address it has to divide 8 address to one sub-block, 11 address to another sub-block and 6 address to another sub-block. Okay, so for example in this organization, for example there are 3 sub blocks or 3 department we can say, for example lab 1, lab 2 and lab 3. So to lab 1 it has to give 8 addresses, to lab 2 it has to give 11 addresses and to lab 3 it has to give 6 addresses. Okay, so in subnetting, whatever the number of addresses they have asked for sub block, we are going to give 2 more addresses than demanded. It means that for lab 1 we are going to give 8 plus 2, that is 10 addresses. Why? Because first addresses can be used at network address and last address can be used at broadcast address. Again similarly in lab 2 we are going to use 11 plus 2, that is 13 address, and in lab 3 we are going to use 6 plus 2, that is 8 addresses. Fine, so let's design the subnet. So I'll be showing you this how to design. So first of all, the first case is lab 1, okay, which they have demanded 8 addresses. Okay, but as I told you, we have always to give plus 2 addresses, hence we will be giving 10 addresses. Fine, so as the ISP has given us the IP address 17.12.40.0, okay, so for this particular block, first of all we have to find the net ID after slash, because we are going to do the CIDR notation. It means that according to the number of addresses that has been asked, we have also to change the net ID. Fine, so first step will be we have to find the net ID, that is after slash what will be the net ID. So how to find that? So the number of addresses that has been asked, so 2 to the power what will be greater than and equal to 10. So of course 2 to the power 3 is 8, so 2 to the power 4, that is 16 will be greater than equals to 10. Okay, so this 4 will be HID, this 4 will be HID. So as according to the formula, we know that NID plus HID equals to 32. Hence, NID will be 32 minus 4, which is 28. Okay, hence we know that the IP address that is used that we will use in lab 1 will be 17.12.40.0/28. Okay, so in every subblock, while designing each subblock, we have to find this slash. After that is NID, or after slash the notation. Okay, so this is the first step. Hence, let's go to next step. So we got our IP address, that is 17.12.40.0 slash 28. Okay, so let's find the, for lab 1, let's find the first address. Okay, so of course the first address will be 17.12.40.0/28. So how many addresses does it need? It needs 10 addresses. Yes. Hence the last address will be, remember, if you start from 0 and if you want to find the last address, you have to always do plus how many addresses they have asked, that is plus 10, okay, and minus 1. Okay, but for these 10 addresses, okay, we have already asked 2 to the power 4. Remember, while giving the number of addresses, we have to always give in the form of 2 to the power. So we cannot give this 10 addresses. Okay, we have to give 2 to the power, that is 16 addresses. We need 10 addresses, but we will allocate 16 addresses. Okay, so the last address you can find by doing plus 16 in 0, and that will become 16, and minus 1 from that, because we are starting from 0. This is just the mathematical calculation. Hence it will be 15. So the last address will be 17.12.40.15/28. Okay, so why 15? Why we have put the 16? Because in order to fulfill 10 addresses, we will need 2 to the power, that is 16 addresses. Okay, so this is the number of addresses that we'll be allocating, but we know that we need only 10 addresses. Hence the remaining 5 addresses will be wastage. Okay, so in order to find the 10th address, what we'll do, you can do in 0, you can do plus 10 and minus 1, that will be 9. Okay, so here we can write here 17.12.40.0/9. So this will be the usable range. It means that only this much address we are going to use, and from 9 to 15 this much of address we are going to waste. Okay, because we always allocate the address in the form of 2 to the power. Fine, so this is the last address, 17.12.40.15. Let's go to design lab 2. Okay, so for lab 2, okay, so what was the last address in lab 1? It was 17.12.40.15. So in lab 2, the address that we will start from 17.12.40.16. Now what is the NID for this lab 2? Okay, so in order to find the NID, we have to know how much addresses we need. So as in lab 2 they have asked 11 address, but as I told you, we have to add plus 2, so we need 13 addresses for this. So 2 to the power, how much will be greater than equal to 13? Okay, so again 2 to the power 4 will be greater than equal to 13. So 2 to the power 4 means 16. Okay, so here HID will be 4, and NID again we can find with 32 minus 4, that is 28. So in similar case as lab 1, the slash will be 28. Okay, so now let's start to design the subnet. So okay, so the first address for lab 1 will be 17.12.10.16/28. Okay, so can you tell me what will be the last address? So the last address will be, as we are going to assign 2 to the power 4, that is 16. So the last address will be 16 plus 16, that is 32, minus 1, that is 31. So the last address will be 17.12.10.31/28. But we only need 13 addresses. We only need 13 addresses. Okay, so in order to find 13 address, what we have to do, we have to add 13 here, that is 16 plus 13, which will be equal to 29, and minus 1, it will be equal to 28. So here 17.12.10.20, sorry, it was not 10, I think it was 40. Okay, 40, yeah. So 40.28/28. So this is the usable range. It means that we only need this much address, and remaining from 28 to 31, the remaining address is wastage. Okay, so here I think in previous case I didn't find the subnet marks for this. Okay, so in subnet marks, how to find that? We have to make the number of bits of NID as 1 and number of bits of HID as 0. So we can see there are 28 bit. Even the subnet marks for lab 1 will be same as this subnet marks. So 28 bits you have to make as 1 out of 32. So 1, 2, 3, 4, 5, 6, 7, 8, 9 dot 9, 10, 11, 12, 13, 14, 15, 16 dot 17, 18, 19, 20, 21, 22, 23, 24 dot 25, 26, 27, 28. Okay, 28 done. So 29, 30, 31, 32. And if you solve this, you will get 255.255.255.240. So this is the subnet marks for lab 2 as well as lab 1, because the NID was same in lab 1 also. Okay, so what is the last address of lab 2? I think it was 40, 17.12.40.31. So in lab 3, what will be the starting address? It will be 17.12.40.32. And what will be the slash? That we have to find. Okay, so let's go to lab 3. So for lab 3, the address will be 17.12.40.32. What will be the net ID? We don't know. So it needed 6 addresses, but we have to give plus 2, that is 8 addresses. So 2 to the power, what will be greater than equal to 8? Of course, 2 to the power 3 will be greater than equal to 8. Hence, HID is 3, NID is 32 minus 3, that is 29. Hence, the slash will be 29 here. Fine, so let's go and find the first address. So the first address for this will be equal to 12.40.32 minus 29. Okay, so how many addresses it needed? So it needed 8 addresses, hence 32 plus 8, that is 40, and minus 1, that is 39. Hence the last address will be 17.12.40.39/29. But how many addresses it actually needed? Yes, it also needed 8 addresses. Yes, hence there will be no wastage for this. All this will be the usable range. What will be the subnet marks? So 29 bits, make it as 1, remaining bit make it as 0. So 1, 2, 3, 4, 5, 6, 7, 8 dot 9, 10, 11, 12, 13, 14, 15, 16 dot 17, 18, 19, 20, 21, 22, 28, 24 dot 25, 26, 27, 28, 29 dot 0, 0, 0. Okay, so if you solve this, you will get 255.255.255.252. Okay, so you got here first address, you got here last address, you got here usable range, and you got here subnet marks. So this is the complete subnetting of lab 1, lab 2, lab 3. Similar numerical I have done, I have posted in this my website. So subnetting numerical portion, you can go and see similar way I have solved here. Okay, fine. I think yeah. And also I have put two more questions for practice, so you can practice this question also. If you have any query, please let me know. And best wishes for your exam. Thank you.